Today's topic is elementary group theory. Elementary group theory. Yes. Now, firstly, we have to start from binary operation. Binary operation. Binary operation is an operation which contains two or more elements of a set to form a new element of the same set is called binary operation. Is called a binary operation. In general, that binary by means two operations. From among the three, also by two and again by two we will operate that the operation. And for example 1, 2 and 3, all these three are belongs to n, means natural number n, where n is the set of natural number. Then for example, I will operate plus 1 plus 2, that result is 3, which is also belongs to n. This is a binary operation. Here 1 plus 2 is 3, 3 belongs to n. So here plus is called, this operation is called binary operation on n. Similarly, we can try it for multiplication operation. Yeah, plus is binary operation, sometimes product or multiply is also can be the binary operation. This is binary operation. And examples, let me show you. If f such that s times s to s, where s is a set, the product of two any elements of the same set is as yes. In that case, yes, uh, such operation will be binary operation. We can define the set in R1. And similarly, f z plus z equal z, where z is a positive integer. In such case also we can find sum of any two positive integer is positive integers. If that verified, that is binary operation. We can define in this way also. Or if such that n times n tends to n, where n is a natural number. So these are few examples. To understand the binary operation, we can use them. For more details, while discussing the examples, it will be more clear. And about notation of binary operation. Notation of binary operation. Notation of binary operation that can be used like the symbol asterisk, that empty set, dot, multiplication sign within a circle, or subtraction sign, or this plus sign, or triangle, etc. are symbol notation. Suppose we can use a asterisk b. This shows the operation. A dot b shows the operation a dot b. So we can use this symbol or the notation in the binary operation. And the next part, two of the most common binary operations on Z, that is integers, are addition operation, and addition operation denoted by plus, and multiplication operation denoted by cross sign or multiplication sign. So most commonly used operation in integers are multiplication and addition. This is just for information. Now moving to properties of binary operation. Properties of binary operation. There are few properties of binary operation. Properties. Firstly, identity property, IDENTITY, identity property. As we know that 0 is additive identity, ADDITIV, additive identity, and 1 is multiplicative identity. It means if we add 0 in any numbers, we will get the same number. That's why that is additive identity. That will not change the form of the given number. And 1 is the multiplicative identity, means if we multiply any number by 1, we will get that the same number. It will not change. 1 will not change the form of the given number after multiplication. That is identity. And we know that is inverse about inverse. For this, for any integer n, minus n is additive inverse. Yeah, is n plus minus n equal to 0. The sum is identity. That's why for any integer n, minus n is additive inverse. And next one is associative properties, ASSOCIATI, associative properties. In this associative properties, for any integers that is m, n and p, m plus n plus p equal m plus n plus p. This is of addition. Associative properties of addition is m plus n plus p equal m plus n plus p. You'll get same result. And multiplicative m times n times p equal m times n times p, this is of multiplication. As we know that if we add these two number and then adding m, they equal to the first, if we add this m and n and then p, that will be the same result. If we obtain the same result, that was associative property, and in product also the similar condition. And the next about commutative property, COMMUTATIV, commutative properties. This for this also, for any integers m comma n, m plus n equal n plus m, this is of addition, and m times n equal n times m, this is of multiplication. This is of multiplication. Commutative property, that is also in binary operation. And the last is distributive properties. Distributive properties, in this case for any integers m and p, for any integers m, n and p, m times n plus p equal m times n plus m times p. This, or m plus n times p in the right side, that is n times p plus n times p. This is distributed properties. In this way we can discuss this. We can these are the properties of binary operation. We can use in binary operation. These properties we can use. Now we have to move to the next very important part, that is Cayley's table. Very important. Cayley's, Cayley's table. It is simply called composition table. Composition table, or also called operation, OPERATION, operation table. This is also called operation table. Now how can we make this table? For that, one question will be best. Prepare a Cayley's, Cayley's table under a binary operation, under addition modulo 3, under ADDITION, addition modulo 3. I will tell details about this after this problem. Here just I will use and I will define what is addition modulo 3 of, it is denoted by +3, of g equal 0, 1, 2, and also find the identity element, and inverse elements of 1 and 2. Suppose this question is given to us. From this question itself we will learn about Cayley's table or composition table or operation table, how to build up this. We will do that, we will solve this. Now the solution of this, here we have given g equal 0, 1, 2. These are the elements of this. Let +3, that is addition modulo 3. plus 3 denotes the addition modulo 3 modulo of 3. Now Cayley's table or composition table. For this, if we have 3 elements, then we can draw 4 cross 4 table, or simply it is understood that 1 2 3 4 1 2 1 2 3 1 2 3 4 1 2 3 4 1 2 3 and sorry 1 2 3 4 1 2 3 4 1 2 3 4. So I will make 4:4 table. One, two, three, four, 1 2 3 4 1 2 3 4. Yes, we have to draw 4:4 table because here we can write plus 3 modulo, yeah, modulo addition modulo 3. That operation we can write that this is operation we can write asterisk plus or plus 3 plus 5, we can write that. And in the vertical and horizontally we can write the elements 1 0 1 2 0 1 2. So we need, if 3 elements are given, we need 4 cross 4 table. If 4 elements are given, 5 cross 5 table we need. Just be in a first row and first column we can write, we can copy the elements. Now addition modulo 3 we have to add, but what is the consequence I will tell you. 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, no doubt we can write easily. 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2, here we cannot write 3. In addition modulo 3, like we can compare like binary number, quinary number, we cannot write. In binary number we cannot write 2, in quinary number we cannot write 5, and decimal number we cannot write 10. 0 to 9 digits are there. So in addition modulo 3 we cannot write 3. Then what can we do? 1 plus 2 sum is 3, the sum of 1 and 2 is 3, then 3 is divided by 3. Addition modulo 3, that's why we have divided by 3. In some cases subtracting 3 may be written, but the best answer is this: 3 ones are 3, the remainder is 0. That's why you can write here the remainder. You can write here the remainder. What I am telling, the sum of 2 digits divided by addition modulo 3, that's why 3, and the remainder is written in the table. That's why 2 plus 0 is 2, 2 plus 1 is 3, that is 0, and 2 plus 2 4. 4 is divided by 3, 1s are 3, the remainder is 1. That's why here you can write 1. And in general sense, if there is 3, that is 0, there is 3 is 0, 4 is 1, 5 is 2, 6 is now 6. 6 is 3 2 just 6, no remainder, that will be 0. If that is 6, multiple of 3 will be 0. 3 and multiple of 3 are 0. In other case you can write the remainder. In this way we can make this table. We can make this table. It is called Cayley's table. And then now we have to identify identity elements of 1 and 2. Identity elements of 1 and 2 we have to find. Now look at here. Identity elements means what? Identity elements is after the operation we will get the same number. That if two numbers are added, then if we obtain the first number, the second one is identity number. So from the table we can observe the table. It is clear that 1 plus 0 equal 1, 1 plus 0 equal 1, and 0 plus 1 also equal to 1. Therefore 0 is the identity element of 1. First case is that. And again 1 plus 2 equal to 0 and 2 plus 1 also equal to 0. Therefore 2 is the inverse element of 1. Let me repeat it again. 1 plus 0 is 1, 0 plus 1 is 1, so 0 is the identity element, because 1 plus something, 0 is added to 1, we will get the same number. And for 2 also, 2 plus 0 is 2, yes, for 2 also the same. And you can write, this is for 1 I found, and 2 for 2 plus 0 is 2, 2 plus 0 plus 2 is 2, that's why 0 is the identity element for 2 also. And for 2 also, yeah, you can write that 0 is the identity element of 1, and for 2 also, because 2 plus 0 is 2, identity element, no doubt. Now we have to move to the inverse element. Inverse means what? The sum should be 0. Sum of two numbers, if the sum of two numbers is 0, then that number is inverse number. So 1 plus 2 equal to 0 here, 1 plus 2 equal to 0, that's why the inverse of 1 is 2. Similarly, inverse of 2 is 1, 2 plus 1 is 0, that's why inverse of 2 is 1, 2 is the inverse of 1, and 1 is the inverse of 2 as well. So we can find sum, if sum is 0, then one number is the inverse of another number, and if two numbers are added and we obtain the same number, then other number is identity number. In this way we can prepare Cayley's theorem. This is first part. Now move to the next example. Let's see the next example also. Number 2 number questions of this. Prepare a Cayley's table under a binary operation under addition modulo 5, that is denoted by plus 5, and multiplication modulo 5, that is times 5, of the set z equal to 0, 1, 2, 3, 4. And now the solution, just how to make the table I will show. First the Cayley's table are as follows under both condition. Firstly, operation is, if there are 1, 2, 3, 4, 5 elements, we have to make 6 cross 6 table. We have to make 6 cross 6. So here I have written plus 5 modulo 5, addition modulo 5. Here you can write 0, 1, 2, 3, and 4. And here 0, 1, 2, 3, and here simply 4. We can make a closed table of this. Then I will complete this table. This is addition modulo 5. So 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4. There won't be 5 and multiple of 5, yes. So 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and 1 plus 4 is 5. 5 divided by 5 is 0, remainder is 0, that's why here we can write 0. And similarly 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 5 is 0, 2 plus 4 is 6, 6 is 1. Remainder will be 1 divided by 5. 3 plus 0 is 3, 3 plus 1 is 4, 3 plus 2 is 5 is 0, 3 plus 3 6 is 1, 3 plus 4 7 is 2. 4 plus 0 is 4, 4 plus 1 is 0, 5, 5 is 0, and 4 plus 2 is 6, 6 is 1, 4 plus 3 is 7, 7 is 2, and 4 plus 4 is 8, 8 is 3. In this way we can make the Cayley's table under addition modulo 5. And similarly here we can make the Cayley's table under multiplication modulo 5. So here also we can write the next table under multiplication modulo 5. Here you can see here you can write 0, 1, 2, 3, and here 4. We can close this. And here 0, 1, 2, 3, and 4. You can remove the unnecessary part. This part we can remove. Now this case also same. 0 times 0 is 0, 0 times 1 0, sorry 0 0 0 0, and 1 times 0 is 0, 2 times 0 0. This vertical and horizontal is all zeros. Now 1 times 1 is 1, 1 times 2 is 2, 1 3 is 3, 1 4 is 4, no doubt. 2 1s are 2, 2 2s are 4, 2 3s are 6, 6 divided by 5 remainder is 1, 2 4s are 8, 8 5 divided by 8 is remainder is 3. You can write here 3. And 3 1s are 3, 3 2s are 6 is 1, 3 3s are 9 is 4, and 3 4s are 12 is 2 5s are 10, remainder is 2. And 4 1s are 4, 4 2s are 8, 8 is 3, 4 3s are 12, 12 is 2, 5 2s are 10 and remainder is 2, 4 4s are 16, 5 3s are 15 and remainder is 1. In this way we can develop Cayley's theorem under addition modulo 5 and multiplication modulo 5. Now the next part is about congruent modulo m. Congruent modulo m. We have to define this. Firstly, if a positive integer a is divided by a positive integer m, if a positive integer a is divided by a positive integer m, then we get positive integers k and b, both k and b smaller than m, is the quotient and the remainder, quotient k and remainder b respectively. Then we call is a congruent congruent a congruent b modulo m. and it is written as A 3 lines B mod m. It is written as A congruent B modulo m. A congruent B modulo m. Then we can clarify A by m equal, that implies m A is divided by m k times here something and subtracting remainder is b, and it is simply written as A congruent modulo B mod m. Real example, suppose 7 divided by 2, that implies 2 7 2 3s are 6, remainder is 1, and it can be written as 7 congruent modulo 1 congruent 7 congruent